The world took a step towards our goal of harnessing nuclear fusion as an energy source last week, with the construction officially beginning of ITER. This is the International Thermonuclear Experimental Fusion Reactor. The project was officially launched by Reagan and Gorbachev as a collaboration back in 1985, and now 35 countries are involved in making parts for the reactor, which is being assembled at Cadarache in France. It's going to take years to put it all together. Fusion is regarded as a promising energy source because it's what makes stars, including our own sun, shine. In there, though, at very high temperatures and pressures, smaller atoms are squeezed together to make bigger atoms, and energy, which we see as sunlight, is released in the process. Now, if we could make that happen sustainably on Earth, it could be a clean source of energy because the raw materials to make it work are very plentiful, it's potentially carbon neutral, and the waste products are much safer than the highly radioactive material resulting from the present generation of nuclear power stations. Michiel Clissens is the author of the book ITER, the Giant Fusion Reactor, and he spoke to Adam Murphy about the project.
The research started 50 years ago already, so there have been more than 100 small reactors built in the world. ITER will be the biggest one ever constructed, and it has been specifically designed to produce energy. If it succeeds, it will open the doors to, I would say, industrial development and new machines that will demonstrate that this technology can work, but also can have an industrial interest.
Then what are the challenges that they're going to have to get past to make fusion work?
Yeah, 3,000 people working in Cadarache, in this village in France, are starting building the reactor, assembling the components, 1 million components that are manufactured in the 35 countries. Hopefully, in 5 years' time, the reactor will be completed and the first experiments will take place. 10 years later, in 2035, the plant will be completed, and then the operators will start the nuclear fusion reactions. Then the next steps will be to build maybe an even bigger machine. ITER will not produce any electricity. It is and it will remain an experimental facility.
That makes it clear that it's a massive engineering challenge, but what is it that makes fusion so hard to achieve?
Well, in a way, it's easy to achieve since it's probably the most common reaction in the universe. All the stars are doing this. So, in a way, it's very common. The main difficulty is to reach 150 million degrees. You don't need to be a scientist or an engineer to realize how impressive, how big it is. It is possible. You just need to use some technology tricks to contain the gas at such high temperature, because you cannot put a gas in a bottle at 150 million degrees. So the trick is to create a sort of magnetic cage with huge magnets. There will be about 40 that will contain the plasma and prevent the charged particles to touch the inner walls of the reactor.
Michiel Clissens speaking to Adam Murphy about the ITER fusion reactor.